Hi friends, through this video I am giving a short explanation of Ncert class 9 chemistry lesson which is really helpful for competitive exams. Let's start our first lesson, matter in our surroundings. Anything which occupies space and have mass that we called as matter. For example, air, chair, car, table, etc. But our feelings are not considering as matter. Matter is made up of small particles called atoms. They have space between them and they are continuously moving. They attract each other. Because of all these properties, matter shows the process diffusion. Intermixing of particles of two different types of matter is known as diffusion. For example, when we'll mix salt into water, we get the salt water. Here, salt is occupying the free space between the particles of water. This intermixing we called as diffusion. Another example, presence of dissolved carbon dioxide and oxygen in water, various gases in air, and dissolving of ink in water. In the case of solid, diffusion is very slow because they are closely packed. In the case of liquids, compared to solid, it's fast. And in the case of gases, diffusion is very fast because particles are freely arranged inside gases. So in this lesson, very important thing is that when temperature increases, the kinetic energy of the particles also increases. Kinetic energy means energy due to motion, so which makes faster diffusion. So always remember that whenever the situation is there, temperature increases, the kinetic energy also increases. Particles will move from their position, they will be far away from each other, and the diffusion will be faster. States of matter: solid, liquid, gas, plasma, and BEC. These are the five states of matter. Solid, liquid, gas, we are familiar with that. Plasma is the fourth state of matter, and fifth state of matter is that Bose-Einstein condensate. Plasma is nothing but ionized gases. Because of the presence of this plasma inside suns and stars, they are showing shining. So BEC, Bose-Einstein condensate, discovered by two scientists, Satyendranath Bose and Einstein. Here they provided gases in extremely low densities. So next we are going to learn about differences between solid, liquid, gas. Solid, they have definite shape and volume, but in the case of liquid they have definite volume, but they are not having a definite shape. In the case of gases, they are not having definite shape and volume. Maximum force of attraction between the particles are present inside the solid, and in the case of liquid they are having less force of attraction compared to solid. In the case of gases, negligible force of attraction between the particles, because in the case of gases particles are farly arranged. And in the case of solid, we can compress. No, we can't compress. But in the case of liquid and gases, we can compress that. Kinetic energy of the particle is minimum in solid. More than solid is there in liquid, and maximum kinetic energy is there in gases. Solids, they are rigid, they may break under force but difficult to change the shape. In the case of liquid, the particles can slide over one another, and in the case of gases, particles can move very freely. In the case of solid, they can't flow, but in the case of liquid, they can flow, and gases also can flow. Solid having high density, and compared to solid, liquid having lower density, and gases having very low density. Density means mass per volume, means how heavier the object in a unit volume. Next we are discussing with state of change of matter. Solid, when we are providing heat, it converts to liquid, and again we are providing heat, liquid will convert to gas. Again, when we are cooling the gas, you will get liquid. Again, if you are cooling the liquid, you will get solid. What is actually happening here? When temperature increases, kinetic energy also increases. Because of that, the force of attraction between the particles start leaving their fixed position. So they are moving freely, means they will be away from each other. So solid start converts to liquid, and liquid convert to gas. In the case of when temperature decreases, the kinetic energy of the particles also decreases. The force of attraction between the particles increases. The particles start moving close to each other. That leads to conversion of gas into liquid. Again the process continues, means liquid into gas. Next we will learn about the process of conversion. Conversion of solid into liquid, that process we called as fusion or melting. The temperature at which solid convert to liquid, that particular temperature we called as melting point. For example, melting point of ice is that 0 degree Celsius. The process of conversion of liquid into gas, that we called as vaporization. But the temperature at which liquid convert to gas, that particular temperature that we called as boiling point. Boiling point of water is 100 degree Celsius. Conversion of gas to liquid, that we called as condensation, and liquid to solid, that we called as solidification. And there is another process of conversion of solid into gas directly. There is no liquid phase, that we called as sublimation. The things like ammonium chloride and camphor, which shows the process sublimation. When we are providing heat to camphor, it's familiar to us. It's we can't see any liquid phase there. Directly it will convert to gaseous states. Always remember that 0 degree Celsius is equal to 273 Kelvin. So how to convert degree Celsius to Kelvin? Plus 273. Whatever degree Celsius they are providing, add 273 along with that, you will get a Kelvin. And then if you are having the Kelvin, how to convert degree Celsius? Whatever Kelvin they are providing, minus 273 from that, you will get degree Celsius amount. So 0 degree Celsius is known as 273 Kelvin. So process of conversion of solid to liquid, fusion or melting, the temperature at which solid convert to liquid, that we called as melting point. And the process of conversion of liquid into gas, that we called as vaporization. And the temperature at which liquid melt and forming gas, that particular temperature we called as boiling point. Next, we are going to learn about effect of change of pressure. By applying pressure and reducing the temperature, we can liquefy the gases. Example, LPG, CNG. Inside cylinder, both are in the form of liquid. LPG, we are familiar. In home, we are using that gas. LPG means liquid petroleum gas and CNG means compressed natural gas. When we are opening the lid, what is happening? Cylinder, inside the cylinder, the liquid is coming outside pressure is different from the inside the cylinder, so suddenly they convert to gaseous form. Dry ice is means solid carbon dioxide. So solid carbon dioxide is known as dry ice. What is evaporation? The phenomenon of change of liquid into vapor at any temperature but below its boiling point. If you are taking about water, boiling point of water is 100 degrees Celsius. Below 100 degrees Celsius, water is converting to gas, that we called as evaporation. Then there are some factors which affect evaporation. When surface area increases, temperature increases and wind speed increases. These all things makes the evaporation faster and increase in the evaporation. But in the case of humidity, means water content present in the air, which decreases the evaporation. How evaporation causes cooling. The particles absorb energy from the surroundings in order to compensate the energy that being lost in the process of evaporation. This result in the cooling of surrounding area. For example, when you are putting some acetone in your palm, acetone means normally nail polish remover or nail paint remover, you can see that acetone. We will feel after sometimes we will feel cool. What is happening there? Acetone is taking heat energy from our palm and it's evaporating, converting into gas, so we will feel cool. So another one example, people sprinkle water on the roof or ground on the sunny days to cool the area. Actually in the sunny days the area will be ground or roof, it will be very hot. At that time when we are sprinkling water absorb that heat and it convert to gas. All the heat is water absorbed means we will feel cool. Our second chapter is that matter around us pure. Matter can be divided into two, pure substances and impure substances. Impure substances means mixtures. Example of pure substance is that elements and compound. Mixtures may be divided into two, homogeneous and heterogeneous. First we will discuss about pure substances. Pure substances means substances which are made up of same kind of particles. Which may be elements or compound. First we will discuss about elements. Elements are basic form of matter that can not be broken down into simpler substances. For example, carbon, hydrogen, oxygen, nitrogen, etc. Elements may be metals, metalloids and non-metals. Metals means which shows malleable, ductile, good conductors, conductor of heat, have a luster. Luster means shine. Malleable, ductile means make thin sheets. They are sonorous means while beating it provides sounds. Example gold, copper, iron. Metalloids which shows the properties of both metals and non-metals. Example boron, silicon. Non-metals means which is not sonorous. They are not malleable. They are not ductile. They are bad conductor of heat and electricity. Example hydrogen, oxygen, etc. Compounds are composed of two or more elements in a fixed proportion. Example water, H2O, carbon dioxide, CO2, salt, NaCl, methane, CH4. Mixture which are constituted by more than one kind of pure form of matter, which may be homogeneous or heterogeneous. Homogeneous means uniform composition of particles not visible to naked eyes. Heterogeneous means non-uniform composition and visible to naked eyes. And example sugar in water. When we dissolve sugar in water, we can't see the particles of sugar again, but here in sand we can see particles of sand, particles of stone, other decayed material also. In water, in oil, when we dissolve oil in water, we'll can see two layers, that downside water and upside the oil. Homogeneous mixture, example is solution. Solution is forming by dissolving solute and solvent. Solute is means whichever particle is present in the lower amount, that we call as solute. In a solution, which particle is present more, that we call as solvent. Sugar solution, in that sugar will take less and water will take more. So here sugar is solute and water is solvent. So solute and solvent make the solution. Example of gaseous solution is that air. Example of water solution is that sugar solution. Example of solid solution is alloy. Alloy is a mixture of two or more metals or non-metals. Example brass. Brass is the combination of zinc and copper. Bronze. Bronze is the combination of zinc and tin. Another example, steel. Various type of solution. Solution may be unsaturated, saturated and concentrated and diluted. Diluted means the amount of solute is very less in that solution. That solution we called as diluted. Unsaturated solution means a solution in which we can add more amount of solute as it not achieved its saturation level yet. So more and more solute, when we can divide in a or dissolve in a solution, that solution we called as unsaturated solution. Concentrated solution means more amount of or large amount of solute is present in a solution, that we called as concentrated solution. So saturated solution, a solution in which no more solute can be dissolved. No more solute can be dissolved since it's already dissolved maximum amount of solute. That's the type of solution we called as saturated solution. So if you want to calculate the concentration of solution, there are two formulas. If they are providing mass in that solution, you can use the formula concentration by percentage, concentration by mass. Or if they're providing volume, you can use the formula with the help of volume. So first one is that mass of solute divided by mass of the solution into 100. And if they are providing volume, you can use volume of solute divided by volume of solution into 100. What is heterogeneous mixture? Heterogeneous mixture, the part is non-uniform composition and particles we can see with naked eyes. Homogeneous mixture, there are two types, suspension and colloids. Suspension means solute particle do not dissolve but remain suspended throughout the medium. When we know in a solution, whatever suspension or any other solution, there will be two substances which is making a solution, solute and solvent. Here solute will not dissolve completely in a solvent, so that type of solution we called as suspension. Example, mud in water. We can see that they are unstable. When we keep that mud water undisturbed, we can see downside, all the mud will be deposited on the down, and upside water we can see. Colloid is a uniform composition of two or more substances. The particles are relatively very small that a solution appears as homogeneous mixture, but it is not. Actually, it's heterogeneous. What is Tyndall effect? The scattering of beam of light by the colloids that we called as Tyndall effect. We can see the path of light in that solution. For example, when a ray of light enters in a dark room, it is scattered by the dust particles, the presence in the air, and we can see the path of light clearly. And the canopy means in thick forest, and light is coming from the branches. So these in picture you can see it clearly. This process to be called as uh, Tyndall effect. Next we are going to learn about separation techniques. There are many separation techniques. One by one we will discuss. First one is that what is evaporation. The technique and what type of mixtures we will separate by using evaporation. And what is the application of that evaporation. First, we'll discuss about homogeneous mixture. First one is that solution. Solute and solvent together making solution. In that, which component is present more that we called as solvent and which component is less that we called as solute. For example, sugar solution. Always we will use more water and less sugar. So water is known as solvent and sugar is known as solute, making together sugar solution. So the solution may be three types: solid solution, liquid solution, and gaseous solution. Liquid solution may be sugar solution, gaseous solution may be air. But in the case of solid solution, example is that alloy, the mixture of two or more metals or non-metals that we called as alloy. Example, brass. Brass is a combination of zinc and copper. There approximately 30% of zinc will be there and 70% of copper will be there. Then bronze is a combination of zinc and tin. Here is steel. To make steel, they'll combine iron and carbon, one metal and one non-metal, etc. Different types of solution. Solution may be diluted, concentrated, unsaturated, and saturated. Diluted solution make unsaturated solution and concentrated solution may be saturated solution. Diluted solution means the amount of solute will be very less in that solution. Next we will discuss about what is unsaturated solution. In a solution, we add more amount of solute as it not achieved its saturation level, that we called as unsaturated solution. Means whatever solute we will add, full solute, they are ready to dissolve. Concentrated solution means already large amount of solute is dissolved in that solution. That type of solution we called as concentrated. Saturated solution means a solution in which no more solute can be added since it's already dissolved the maximum amount of solute. To calculate the concentration, we can consider the formula like percentage by mass and percentage by volume. In question, if they provide in case of mass of a solute or mass of a solution is provided, you can use the first formula. Or in question, they are provided the volume of solute or volume of solution, you can use the second formula. To calculate the concentration, first formula is that percentage by mass of solution divided by mass of solute divided by mass of solution into 100. If they are providing volume of solute divided by volume of solution into 100. So next we will discuss about heterogeneous mixture, that is non-uniform composition. Particles can be seen by our naked eyes. This heterogeneous mixture, either they may be suspension or colloids. Suspension means in that solution, solute particle do not dissolve but remain suspended throughout the medium. In solute dissolve in solvent, that makes a solution, but here solute will not dissolve, it remains suspended throughout the medium. So example, mud in water. So mud in water, when we'll take that mud in water, if you keep undisturbed, sometimes you can see mud will come down and it will settle down and water will be upside. It's unstable solution. Colloids, uniform composition of two or more substances. The particles are relatively small, that the solution appears as homogeneous, but actually not. What is Tyndall effect? The scattering of beam of light by the colloids is known as Tyndall effect. We can see the path of light in the solution. Example, When a ray of light enters in a dark room, it is scattered by the dust particles. We can see the path of light very clearly. Another example is that canopy. Next, we are discussing about separation technique. First one is that evaporation. Uh, Evaporation, for example, a mixture of volatile substances and non-volatile substances are there in a mixture. So we will separate that type of mixture by using evaporation. Volatile substances means which will show evaporation. The substances which show evaporation that we called as volatile. The substances which will not show evaporation that we called as non-volatile substances. When we'll use all the evaporation means separation of color component from the ink and salt from water. To process also we'll use the technique evaporation. Next process is that centrifugation. Separation of dense particle from a lighter particle will go for centrifugation. Application: separation of blood cells from blood, separation of milk from cream, separation of butter from cream, squeezing out water from wet clothes. Especially in the case of colloids, we will follow the technique centrifugation. Next separation technique is that separating funnel. To separate two immiscible liquid, we will use separating funnel. Immiscible liquid means liquid which will not mix properly. Means whenever we are mixing that liquids, it will be forming two layers. Example: oil from water. To separate oil from water, we will follow separating funnel, because we know oil and water will be forming separate layer. Next process is sublimation. To separate sublime from a non-sublime. Sublime means which will show sublimation, that we called as substances sublime, and the substances which will not show sublimation that we called as non-sublime. So for example, ammonium chloride, camphor, naphthalene poles, all these things are sublimes, means which shows sublimation. So to separate all these things from any other substances or mixture of any other substances, we will go for sublimation. Next separation technique is that chromatography. To separate colored substances, we will go for chromatography. Application is that to separate color in a dye or pigments from natural colors, drug from blood, all these processes we will go for chromatography. Next process is the distillation. To separate miscible liquids. Miscible liquids means liquid will mix thoroughly with each other. We will go for distillation when their boiling point, differences between their boiling point is above 25 Kelvin. Example: acetone and water. Fractional distillation is the process when we will use this, means in the case of miscible liquid only, but the differences between their boiling point will be less than 25 Kelvin or 25 degrees Celsius. Example: alcohol and water. Another one example is that to separate the gases, different gases, that process also we will use the same fractional distillation. Next process is that crystallization. To purify the solids, we will go for crystallization. Example: purification of copper sulfate and purification of salt. Next, very important topics. Uh, what is physical change and chemical change? What are the differences? What are the examples? Physical change is a temporary change and chemical change is permanent change. In the case of physical change, it is reversible. Once it convert to another substances, again it is reversible. But in the case of chemical change, it is irreversible. In the case of physical change, there is no new substances are formed and energy is not produced. Energy not produced. But in the case of chemical change, new substances are formed and energy is produced also. So here example: melting of ice means when ice melt to form water. Again, if you keep water in a freezer, you will get ice. So it's a reversible change. There is no new substances. Only water is forming ice. Ice is forming water. Butter, melting of butter and dissolving salt in water. All these things are the example of physical change. Chemical change is permanent, irreversible. Burning of paper. When you burn the paper, you will get ash. Again, if you want to convert that ash into paper, it's impossible. Means next chapter, atoms and molecules. The idea of divisibility of matter is given by Maharshi Kanad. Another scientist, Democritus, he gave the name atoms to indivisible particles. Next, law of chemical combination is proposed by two scientists, Lavoisier and Joseph L. Prout. In that, it containing two laws: law of conservation of mass and law of constant proportion. Law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. Here you can see one chemical reaction I given: A plus B gives C plus D. And right and left hand side, whatever elements are there, they are considering as a reactant react together, and right hand side you will write a product. Here mass of this reactant is equal to mass of product. According to law of conservation of mass, law of conservation of mass of reactant is equal to mass of product. Imagine A is having 5 gram and B is also 5 gram. Together 10 gram will be there. Product also always will be 10 gram. More than 10 will not be there. So according to law of conservation of mass of reactant equal to mass of product. Next law is that law of constant proportion. In that law, they states that in a chemical substances, the elements are always present in a definite proportion by mass. Example: water. Ratio of mass of hydrogen to mass of oxygen is always 1 is to 8. If you want to make water, always hydrogen is 1 percentage and hydrogen will be oxygen will be 8 percentage. So when they'll mix in 1 is to 8 ratio, both hydrogen and oxygen, when they'll make to mix with 1 is to 2 ratio, 1 is to 8 ratio, then only we'll get H2 or water. So this laws lacks the explanation. So John Dalton, he gave another theory about matter that we called as atomic theory of Dalton, or Dalton's atomic theory. In that he explained every matter is made up of very small tiny particle called atoms. These atoms are not divisible and cannot be created or destroyed in a chemical reaction. Atoms of a given element are same in size, mass and chemical proportion, but different elements are different in their size, mass and chemical proportions. Atoms combine in a ratio to form compounds, and the relative number and kind of atoms are constant in a given compound. Next, atoms. Atoms are the smallest particles of an element which are take part in a chemical reaction. The size of atom will measure with the help of atomic radius, which is in will express in nanometers. 1 nanometers is equal to 1 by 10 to the power 9 meter, and 1 meter is equal to 10 to the power 9 nanometer. So for example, atomic radius of hydrogen is that 1 into 10 to the power minus 10 meter. Here down you can see some elements than the symbols, and some elements are express the symbols according to their Latin names. Example: sodium, their Latin name is natrium, because of that its symbol is that starting with Na. Potassium, actually its symbol should write P, but here we know the symbol of potassium is K because its Latin name is that kalium. Molecule is the smallest particle of an element or a compound which can exist independently. Molecule may be monoatomic, diatomic and polyatomic. Only one is there we called as monoatomic, two is there means diatomic, or more than two is there we called as polyatomics. Molecules of compound join together in a definite proportion and constitute in a different types of atoms. The number of atoms constituting a molecule that we called as atomicity. For example, water. Water, we know that two hydrogen atoms combined with a one oxygen atom will get water, H2O. Here total two hydrogen is there, one oxygen is there. So total number of or atoms present in this water, or the atomicity of water is 3. Sulfur 8 is 8. Sulfur 8 atoms are there, so the atomicity of sulfur is at 8. What are ions? The charged particles or atoms are called as ions. They are formed by attaining positive charge or negative charge on it. So when atoms are giving electrons or donating electron, they'll get positive charge. So these positively charged ions we called as cations. When they are receiving electrons, they will be getting negative charge. So these negatively charged ions we called as anions. The group of atoms carrying charge, that atoms we called as polyatomic ions. Polyatomic ions. Valence is the combining capacity of an element. Valence is used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. Every atom wants to be stable. So to attain this stability, they may do lose electrons, gain, or they may share electrons. If an atom have 8 electrons in their outermost shell, hence its valence is 0. In periodic table, 18th group, last group elements we called as noble gases, because they are already attained their stability. They will not participate in a chemical reaction. Always they are having 8 electron in their outermost shell, and they are having 0 valency. So they are known as noble gases. Next, what is a chemical formula? Chemical formula we use to represent the composition of a compound in the form of symbols. To write this chemical formula, we know two things. We must know two things: symbols of an element and valency. There are some rules is there to write a chemical formula. For example, chemical formula of aluminum chloride, if you want to write, first you should write the symbol. In this aluminum chloride, which one is metal? That first you should write metal. Next, non-metal you should write. Next one is that charge or valency you can write. Afterwards, cross multiply that, you will get the formula of a compound. What is molecular mass and mole concept? Molecular mass is the summation of all atomic masses in a molecule. Atomic mass is nothing, mass of atom if expressed in atomic unit, that we called as atomic mass. Molecular mass is expressed in atomic mass unit. For example, the molecular mass of HNO3 means nitric acid can be calculated as atomic mass of hydrogen is 1U unified mass, atomic mass of nitrogen is 14U, atomic mass of oxygen is 16U. If you want to calculate that, 1 plus and nitrogen its mass is 14 plus, and oxygen its mass is 16, 3 oxygens are there, into 3 will get 63. Mole is a numerical quantity that have a mass equal to the atomic or molecular mass of a species. 1 mole of a substance is equal to 6.022 into 10 to the power 23 number of particles. It's also known as, this number also known as Avogadro number or Avogadro constant, which is represented by N0. Which is represented by N0. The number of moles we can calculate by using two formula. One is that mass of substances divided by molar mass. Another formula is that number of particles divided by Avogadro number. Next lesson, structure of atom. Subatomic particle of atom includes electron, proton and neutrons. Electrons are negatively charged particles and negligible mass, discovered by J.J. Thomson. Protons are positively charged particles and mass is 1U, U means unified mass, and discovered by Goldstein. Neutrons are chargeless particles with mass of 1U and discovered by Chadwick. Next, we are discussing about the models of atom given by different scientists. First one is that model given by J.J. Thomson. That model also known as plum pudding model. According to him, atom is electrically neutral, consisting of positively charged sphere and electrons are embedded in it. According to J.J. Thomson, in a sphere he is considering as an atom, and this sphere entire charge of sphere is positive, and in that negative charges are embedded, like in watermelon how seeds are arranged. So positive and negative equal charges will be there, so the entire charge of atom is neutral according to J.J. Thomson. So later many scientists came, they proved that his findings are wrong. Next, we are discussing about the model proposed by Rutherford. He performed alpha ray scattering experiment and proposed that atom is electrically neutral with a positively charged nucleus having protons and neutrons and negligibly charged electrons revolving around the nucleus. So Rutherford conducted alpha ray scattering experiment and he found out that inside atom sender will be there which is positively charged, because inside this nucleus positively charged protons and chargeless neutrons are present. Next he said that around around this nucleus electrons are revolving and So the entire charge of atom is electrically neutral because he said that number of proton is always equal to number of electrons. Next, he explained that nucleus will be there, around that electrons are revolving, but he did not explain the stability of electrons. So Bohr, he explained the stability of electron. He said that nucleus will be the middle and electrons will be revolving around the nucleus, but in a fixed orbit, or in a fixed orbits, or with a fixed radius they will be revolving. They will not lose this energy. So who explained the drawbacks of Rutherford? That is Bohr. Bohr explained that how the electrons are arranged around the nucleus. So that scheme we called as Bohr-Bury scheme. So the number of electrons that can be present in a shell, he gave one formula 2n square. When the n is the number of shell he named that KLMNO, it's continuous. K is the first shell. So the electrons are present in the first shell. How to calculate? K is the first shell. 2 is the 2n square formula we should use. The number of n in the case of K, the first shell. So instead of n we will use 1. 2 into 1 square. So it's 2. So in the case of L shell, 2 into 2 square. So it will come 2 into 4, it's 8. Like that you can calculate the number of electrons present in each shell. The maximum number of electrons in the outermost orbit should not exceed 8. Atomic number and atomic mass number. Atomic number is denoted by using capital letter Z. Is the number of proton in one atom of an element. Mass number is denoted by a letter A. It is the sum of proton and neutron present in the atoms of an element. So how we will mention that atomic number and mass number in an element means downside whatever we are writing, that is atomic number, upside we should write the mass number of an element. For example, carbon, it's having atomic number 6 and having mass number 12. So always downside whatever we are writing, that is atomic number, upside that is mass number. Number of proton, atomic number, number of proton and neutron, that is mass number. Next we are discussing about what is isotope and what is isobar. Isotopes are atoms of same element having same atomic number and different mass number. Isotopes are useful as nuclear fuels in medical field and carbon dating. For example, isotopes of uranium is used as a fuel in nuclear reactor. Isotopes of cobalt is used as a used in treatment of cancer. Isotopes of iodine is used in the treatment of goiter, etc. Example, different isotopes of hydrogen is that H11, H12 and H13. Protium, deuterium and tritium. These are the three isotopes of hydrogen. Isobars are the atoms of different element having same mass number but different atomic number. Same mass number but different atomic number. Remember, isotope same element, but in the case of isobar, different element. Hope you understood the lesson. Keep watching and subscribe my channel.